Now, once we have the rules R1 to R5 in the knowledge base, which are nothing but the game rules and the very initial percepts the agent has, we want to move further towards the goal of proving not P12. And this time we will start using the inference rules. Okay, so let me use a different color, let's say brown, and I will write R6. Okay, so R6, which will be biconditional elimination on R2. Okay, R6, so let's say will be biconditional elimination on R2. So what is R6? R6 will be R2 and then biconditional elimination. So what is the rule biconditional elimination? This is here. Okay, so this says if alpha biconditional beta, that means alpha implies beta and beta implies alpha. So let me write it B11 implies P12 or P21. So this is whole thing is within parenthesis, and P12 or P21. I've stopped using the comma just to save space, implies B11. Okay, so after this we will do the AND elimination on R6. AND elimination is what? AND elimination is basically the next rule which says that if there is a AND, so P and Q, that means P is also true. Okay, so what I will do, I will say AND elimination, and this will become R7. Okay, R7, I can take either of them to be true. So I will take the second one. Okay, so that is basically I'll say P12 or P21 implies B11 from R6. From R6 what I did? AND elimination, remember that. Now we will have R8, where we'll apply contraposition on R7. So what is contraposition? If you see, contraposition is this. Okay, so contraposition says is alpha implies beta, that is equivalent to saying not beta implies not alpha. So now R8 will be, so from R7 not B11 contraposition implies not P12, not of P12. You see, I told earlier that this has a higher precedence, so you have to keep it inside parentheses. Not P12 or P21. Okay, so that's R8 after applying contraposition on R7. Now let's see, we will do R9, which will be modus ponens. If you remember modus ponens, what is modus ponens? So if P implies Q and we already know P is true, then Q is also true. Okay, we already said this, if P implies Q and P, and means with a comma, that means P is true, so we can say that Q is also true. So that's modus ponens. So R9 says not B11 implies not P12 or P21 from R8. Now we know not B11 from R4. See, we know that we had that absence of percept in cell 11, which means not B11. That means this part is true. That means this part is definitely true, right? So not of P12 or P21. So this is true. Now what we can do, we can apply De Morgan on R9. So De Morgan is this one, which says that not, so this one I think, not of alpha or beta equivalent to not alpha and not beta. So last we go to the R10, which says from R9 by applying De Morgan's law that not of P12 and not of P21. So what is the meaning of that? This means there is no pit in 1, 2 and there is no pit in 2, 1. See, that's exactly what we wanted to prove, not P12. Derive that. So using the rules and the equivalence statements, the inference rules and equivalence statements, we kind of proved from some basic start point. Okay, so that means this part is proved. Okay, so we'll continue with another rule in the next video.